So in this video, I am going to choose a function, say f of x equal to 2 minus 3x plus 3x square minus x cubed and find out whether it is increasing or decreasing using the first derivative test, using the first derivative. And also confirm the result by drawing the graph of the cubic polynomial. So first let me do the differentiation part of it. F dash of x is equal to minus 3 plus 6x minus 3x square. So if I pull out negative 3, what I will get is x square minus 2x plus 1, which is minus 3 times x minus 1 the whole square. We already know that x minus 1 the whole square will always be positive, being a perfect square, and therefore minus 3 times x minus 1 the whole square will always be negative. Therefore the function f of x is always decreasing. Let us also confirm this by drawing the graph of it. To draw the graph of a cubic polynomial, first we need to find out one of its roots and then go for a polynomial division using long division method or synthetic division and decide the points of intersection with the x-axis. To decide the points of intersection with the y-axis, it is very simple that we can set x equal to 0. By setting x equal to 0 in f of x, I am getting f of x equal to 2. So the point of intersection with the y-axis is going to be 0, 2. To check for the points of intersection with the x-axis, let me take any one point just by trial and error method to find out whether it satisfies. That is the equation f of 1 is 2 minus 3 plus 3 minus 1 not equal to 0. Therefore, x equal to 1 is not a 0 of the polynomial. Let me check for f of 2. f of 2 is 2 minus 6 plus 12 minus 8. It is equal to 0. Therefore, we see that x minus 2 has to be a factor of the polynomial given as 2 minus 3x plus 3x square minus x cube. So, let me go for the synthetic division of 2 minus 3x plus 3x square minus x cubed by x minus 2, that is minus 1, 3. I am arranging it in descending powers of x. So, minus 1, 3, minus 3 and 2. And what is going to be the number that I have to use for division? It is of course 2, because we have understood that x equal to 2 is a 0 of the polynomial. So set 2 here, 0, minus 1, minus 2, 1, 2, minus 1, minus 2, so 0. Therefore the remainder is 0 and the quotient polynomial is minus x square plus x minus 1 equal to 0. We have to find the square root of, the roots of this equation to get the points of intersection with the x-axis. But before that, since we have understood that 2 is a point of intersection on the x-axis, let me set that also. 2, 0 and 0, 2 is the point of intersection with the y-axis. But this minus x square plus x minus 1 equal to 0, we are able to see that the discriminant of this is negative. That is, I will be getting minus 1 plus 4, which is minus 3. And if the discriminant is negative, we know that that equation has only imaginary roots. Therefore, the only real root of the given cubic polynomial is 2, 0. And since the coefficient of x cubed is negative, the curve has to drop from up to down. That is, it has to start in the positive of the y-axis and then drop down to the negative of y-axis. So let me start it here. Go as a smooth curve passing through 0, 2 and 2, 0, and it will go down like this. Therefore, don't we see that it is a decreasing function always. So we have confirmed that the graph of this f of x is a decreasing function by drawing the graph as well by doing it using the first derivative.